All right. How's it going, everybody? Thank you guys very much for coming out, and thank you to the organizers for putting on such an awesome forum. And I don't think Shane is here, but thank you to Shane for such a great talk. My name is Evan. I am a machine learning researcher and engineer at Reducto. Reducto is an API and, at this point, a platform for document processing, document ingestion, document extraction, and now even document editing. So I'm sure many of you guys have startups. A lot of the modalities you guys are probably working with involve ingesting customer documents, whether it's in healthcare or law or fintech. Pretty much all of day-to-day business happens in documents, and Reducto builds the most accurate pipeline to extract data from those documents so that you can go and build all of your amazing RL agents and RL environments on top of those. A little bit about myself. I graduated from MIT a couple of years ago. I did a stint in New York doing high-frequency trading and machine learning models for that. And I've been with Reducto since the summer, helping to lead a lot of the stuff on the machine learning team, helping out with the infrastructure, and helping to improve our inference stack. So, what do we do at Reducto? It started actually right here in Y Combinator with parse. This is like one of the most basic things that you need to do with a document, and it might really shock some of you guys that here in 2025, parse is still not a 100% solved problem by like your generic Gemini or ChatGPT or whatever. But parsing a document can be really hard. And this is one of my favorite examples. It's just from our studio. You can go online and like try it out yourself. And it exemplifies a lot of the really challenging issues that come when you try to parse a document. So just going from top to bottom, the first thing you'll notice is that we have all of these like boxes drawn on the document. These are all in-house models that we've trained that can do layout analysis of the document. So up here in blue, we have this thing that we would call a key value region. Here, we've identified that this is a title, some more key value regions. Over here is a figure where you've got this guy here. We also have information within the figure that you need to extract. And then down here, we have a handwritten table, both with some header regions there, as well as the content of the table. And at Reducto, we train a lot of models. In fact, we have specialized models for almost every portion of this pipeline. So for these key value regions, which have a very special structure to them, there's this evac category key and the value II severe. We have a special model trained just for things like that. These come up a lot in insurance and claims processing. For figures, I'm actually helping to lead a lot of the work that we're doing on specialized models for figure extraction. We'll talk a little bit more about that later. And of course, one of the things I think was like the original bread and butter of Reducto is our table models. This is really important in many settings in finance, for example, where you have like long tables in financial reports. And we have specialized models trained to both interpret the structure of the table. Here it's a relatively easy table where you just have all the rows here. But if you've worked in Excel a lot, you know that you can make all these fancy merge cells, and people love their merge cells. And so we have specialized models for that, as well as extracting the content of the table. One thing that you'll find if you work with documents a lot is that the accuracy of a model tends to decrease pretty dramatically with the text density of the region. It's just more things to output, more opportunities to make mistakes, and tables are like some of the most text-dense things that you can imagine on a page. Our approach to the parse problem is a hybrid one. As I said, we have all of these different models that we train. We have our layout model that does routing. We have models that also do checking on top of it, on top of our entire parse output. And that helps us to maintain top-level accuracy for this baseline level task of parsing. But we don't just do parse anymore. Pretty quickly after that, we found that many people had all these parse documents, but they wanted to get information out of them. They might give us like a 100-page document with all of these insurance claims stapled together. But what they don't want is like all the content in that document. Really, they just need to know what was the claim number, what was the condition, what was the patient name for each of these 100 patients in these 100 documents. And so that's when we introduced extract. So in extract, we'll be given a document like this, and somebody just gives us a JSON schema. They say, I need a security name. That's like the thing that's being traded. I need a symbol. That's like the ticker that you would see on NYSE. I need the shares, et cetera, et cetera. And we will not only fill in that schema for you, but we will also identify exactly where in the document it came from so that you can get human-in-the-loop interpretability and be confident that the outputs are correct. And so that you don't have to check every single field that we output, we also have a custom confidence model, which is trained to directly output how confident we are in the extracted value. And that way you know which values might need a second level of pass if you really need that like 100% level of accuracy. And then finally, this is a teaser, because it's a very new thing. I'll talk a little bit more about it at the end. We also are now doing figures. So we've been pioneering a lot of work in this space to get pixel-perfect extractions from figures. We've seen this a lot from people in the finance space. Say that you're like a big hedge fund and you process all of these reports. There's a lot of information in these reports. And right now, no models can really handle that now. I'd actually encourage you guys, like, go home, try taking a figure like this, put it through GPT-5, put it through Gemini, put it through Claude. None of them will do it very well, unfortunately. It's just like beyond the capabilities of current public vision language models. But we've been developing a lot of very cool research internally to push the frontier here. So that's a little bit about what we do, but what have we been up to? We actually just announced our Series B. It was 18 months from being here in Y Combinator all the way to Series B, led by A16Z. We've raised more than $100 million at this point. And concurrently with that, we also just crossed the 1 billion page mark for pages processed. And that was like incredibly exciting, 2 weeks ago when we did our Series B announcement that the two just happened to line up at that time. Even more exciting is the fact that from start of YC until about 2 weeks ago, we processed roughly 1 billion pages. Just this past week, we processed almost 100 million pages. So the growth curve has truly been exponential, which has been super duper exciting. But that's enough about the business stuff. I think we're all here to talk a little bit about RL and a lot of the challenging problems that we've been solving there. And so I talked about this at the beginning, like it's shocking that here in 2025, almost 2026, document processing is not just like, you call Google Gemini or whatever and it just like solves it immediately. Why is document processing so hard? And I think really what it comes down to is that machine learning is kind of this like magical machine where you take in an objective function that needs to be optimized, and you take people like me and the rest of the machine learning team, and we all work very, very hard to like hill climb that objective function. And if we have a good objective function, we can make like a very good model that like reaches very low loss on that objective function. The problem is that with document processing, making a good objective function is actually very challenging. So I'll go through a couple of examples to demonstrate this. The first ill-defined objective, one of the original ones that Reducto started to solve, was the ordering problem. This is a form region from a thing called an accord form. And the Reducto people in the audience will be very familiar with accord forms. They're very popular in the insurance processing space. And I just want you to think as a human, like, say that you had to linearize the output of this. Let's just say I gave you the content. I'm just giving that to you as a given. How should you actually order things? Should you go, I don't know if the pointer's gonna work. I'll just do it on my computer. Should you like read it like this? Or should you read it like this? Or do you want to like get the small boxes first? There's like many ambiguities. And if you use like simple measures like edit distance, which is just like you have two strings and you try to figure out like how many insertions or deletions it takes to transform one string to another, you can get like dramatically different results from edit distance for two very reasonable orderings. And so as a result, even just defining like what should the ground truth be in a linearized output is very, very challenging for this ordering problem. Another thing that's actually pretty ambiguous is parsing itself. You might think like, the text is on the page, like how hard could it be to read the text on the page? But oftentimes there's implied things within the text itself. This is a table from some very old like Federal Reserve document. And you can see that we have two implications. First of all, where there's like a ... over here. That's actually, I think, kind of important for maintaining the spacing. But ... over here actually just means blank value. Another one that's like particularly tricky for table models, I mentioned these like merge cells. This is like an implicit merge cell right here. The fact that we have 1947 just for January, but not for the following months. Really, like all of these following months should be associated with 1947. If you were to parse this as like 1947 is only associated with January, you're doing the parse wrong. but it's ill-defined. It's like not totally obvious just from looking at the document, whether you just want like the raw parse output or whether you want to apply this like higher order of reasoning to interpret it. And then of course there's layout, which is one of the core functionalities in any document processing task. We have two examples of ambiguity here. Each of the colors here, again, indicate what class we gave to it. So here, this was an older layout model of ours, which took these two tables and labeled them both as like one big table region, which is like technically wrong, but you could also like say, well, this is all just one table, right? So maybe it could be right. Another thing that's really challenging is when you do make mistakes, trying to figure out like what degree of penalty should a mistake cost you. So here, one of the older layout models took this figure and like got most of the figure, but it missed this little piece of text right here. Now it labeled it as text, but like, what should we assign more weight to? Should we assign more weight to the fact that like the text was not associated with the figure region, or should we assign more weight to the fact that like it was correctly identified as a text region and not say a table region, which would be pretty catastrophic as a failure case goes. And so these are like the examples of the ill-defined objectives that you deal with in document parsing that make hill climbing that optimization function really, really hard for any kind of generic modeling thing. So now I want to talk a little bit about solutions. I've mostly just talked about problems, but I complain about problems at work. I don't want you guys to have to suffer through that more. I'm going to talk about this paper that came out this past week, OCR2. Which I think really encapsulated some of the ideas for how you use reinforcement learning to approach these ill-defined objectives pretty well. And this week was actually a very big week for OCR models. I'm not sure if people saw on Twitter, but like DeepSeek released a model, like Allen AI released a model. I think like basically everybody and their mother is like releasing OCR models for some reason now. But this one I think was like a particularly interesting research report, so I want to go through it. All right, so OCR2. How do they define this problem? Well, here was their framing of the ordering problem, which is you have a document right here, and you might have these three regions of text. The figure caption, you have this text step here below on the first paragraph, and you have this text here above on the second paragraph. And I mentioned edit distance before, which is this like notoriously finicky measure of correctness. Now there's multiple correct orderings for these three things. Like what we know for sure is that these two should come together with the green before the yellow, but the red like kind of can be in any order. And if you define what they call a unit test, which I'll explain in a second, you can correctly encode that invariant in the output. Whereas if you just rely on a raw continuous metric like edit distance, you can see that it doesn't correlate very well with the invariant that we know in our mind, which is that this green and yellow have to appear in a particular order with the red not intersecting them. So what are these unit tests that OCR talks about? They defined a couple of them: text absence, text presence, reading order, table accuracy, and math formula accuracy. And all of the unit tests that they defined in their paper are binary. There's no continuous value here, so they don't address that issue I talked about with the layout model, where there's like degrees of wrong. It's just like you either like did the correct thing or you didn't do the correct thing. And to give you an example of some of these tests for text presence, I might just say like here's a string that we know appears in the ground truth. We're just going to make sure it appears in the output that you parsed. For text absence, this is a little bit of an opinionated choice that they made, where they decided that like headers and footers just like should not be in the output for some reason. Candidly, I don't know why that is, but it does make it pretty easy for them to define an absence test at all, because they don't have to go through the infinitude of possible things that could not be in your document. They can just define that rule and then make a text absence test. For reading order, this is one where I think that they took a very particular approach to it. I'll discuss this on the next slide, but they had access to the underlying HTML that made the documents that they were parsing. And so as a result, they were able to just say, like, if two things appeared sequentially in the HTML, they should appear in that reading order. Table accuracy checks for things like, hey, is this value in the table? And also, is this other value like above or below the target value? So like here we might check that 0.6 is above the 0.57, and both of them are contained in the table. And math formula accuracy is a rather complicated unit test that I won't go into, although it is pretty interesting, so I would encourage you guys to read the paper if you're interested in that kind of thing. But I've kind of defined what you would do if you had the ground truth. I think an open question in your mind should be like, how do you actually generate the ground truth thing so that you can make your unit tests and like train your RL model? And here they used a pretty clever approach that we've also used a little bit internally, which is synthetic data. I think a lot of people are thinking about synthetic data right now, and it can be very, very powerful when used in an appropriate way. What they do is they take a real document like this. This is from some Colm paper in 2025. And they send it off to a large language model provider. I think they use Claude, but you could use Gemini, OpenAI, whatever. And they just say, like, please generate HTML that's like roughly like this. If you just try to send these documents to providers, you'll see that they don't do very well. They don't get to that 100% level of accuracy. They can do reasonably well on things like archive papers. I think that if you used a handwritten thing, you'll see that their performance can degrade pretty dramatically. But they can produce valid HTML. But they're very good at least making a thing which is displayable. And that's kind of all that you need to be able to take this approach. If you have some HTML, you can then display it in a headless browser, and now you have like a PDF screenshot, and you have the underlying HTML with it. And so it might not be a real document, but it is hopefully like real enough as a document, similar enough to the original document, that it's not like crazy out of distribution when you try to apply this model in the real world. And so as a result, you get documents, images, and you get ground truth HTML. And from that, you can generate all of the unit tests that we discussed earlier. Are there any questions on that piece of it? We also will do questions at the end in case people want to wait. Cool. All right. Of course, these are all like really cool ideas. I think it's like a very interesting approach. In the end of the day, results are what matter. So this is from their paper. And they take their original OM OCR, which was released, I think, back in like January or so, and they show its performance on a wide variety of different tasks, archive papers, old math scans, tables, standard like old scans, like the kind of things that you might have faxed back in the day, headers, footers, multi-column pages, long and tiny text, as well as just like generic text models. And they ablate out a couple of different choices. This dynamic temperature scaling thing is actually like a very cool idea, but I won't go into it. I would read the paper for that. They improve their prompting. They use Qwen 2.5 VL. They improve their handling of blank pages to avoid hallucinations. And this one right here is the thing that we've been talking about for so long. Their synthetic data pipeline and the reinforcement learning from verifiable rewards. And I think it's interesting both to see like where this does not really help that much and also where it does help quite a lot. So you can see that like for long and tiny text and like for generic documents, this basically doesn't help. But the two places where you see a lot of improvement from taking this kind of approach are on tables and on multi-column pages. Does anybody know like what is common between these two? Go for it.
Spatial.
Spatial, yeah, exactly. Like, this approach works remarkably well for spatial reasoning tasks. That said, it's like very, very important for that kind of thing. You get almost as dramatic of a boost just by like improving your inference parameters. So unfortunately, this is not like an end-all be-all for document parsing. But when you really care about the spatial locations of things, taking this RL approach can actually yield dramatic gains. So, of course, it wouldn't be a reinforcement learning talk if I didn't have like an up and to the right graph and the GRPO equation. So here those are. I don't want to get too much into the details about exactly how we compute the reward here, but this is indeed one of our spatial models. This is the layout model that I discussed earlier. And we applied GRPO to a very custom and like carefully thought about reward function. And you can see that it didn't just improve like a little bit, it like more than doubled our performance on the tasks that we were looking at in layout. And so when applied well and when applied with like a very carefully considered reward function, I think that you can see enormous gains from using RL. All right, so that's a little bit on the RL stuff. I also just want to take some time while we have it to talk about the frontier research that Reducto is doing, in case any of you guys are either looking for a job or know people who are really interested in this kind of stuff. One place that we've already rolled out into production for some awesome customers has been Edit. And so this is like capturing that last part of the document processing pipeline. We already do parse. We can also extract information. But if you just tell us, like, hey, here's the thing that I want edited, we can actually edit the document for you. And this is particularly useful for like compliance companies who might need to have many forms, like the same form that they're filling out over and over again. And right now, or before Reducto at least, they would just be hiring humans to take that data and like put it into a form. But we can actually use agent-in-the-loop capabilities along with computer vision models to identify where exactly we need to fill things in, and then fill in information in those form fields and return back a fully extracted PDF. And then, of course, the other one I want to talk about, which is very near and dear to my heart, is figure extraction. So as I mentioned, this is the task of taking in a figure like this, where we have many of these lines that can at times have like really high curvature to them, and correctly extracting a markdown table. And you can see just how like pixel perfect our extraction can be. I wish I could like zoom in on here, but like I think if you measure any of these data points, they will be 100% accurate. And so this is some really exciting capabilities that we've been pushing the frontier of, and we hope to be releasing to beta testers sometime soon. So if you care a lot about figures in your work, please reach out to us. All right, so that's all that I have right now. But as I mentioned, we are hiring for machine learning engineering, machine learning research, for deployed engineers, GTM, like basically every single part of the company we're hiring. I think we want to like almost double the company by the end of the year. So if these are problems that are really interesting to you, please reach out, reducto.ai/careers, or just email me directly, evan@reducto.ai. And if you are building a product that could really make use of this, right now we have 15,000 free credits as part of the Series B launch. So at absolutely no cost to you, you can go to studio.reducto.ai, sign up, try it out, let us know what you think, let us know if there's places where we can improve, and hopefully we can help you solve all of your document parsing problems. So with that, I think I'm just about out of time. I want to make sure that we save some for questions, and thank you guys very much.